Hello everyone and welcome for the machine design 2 lecture. Previously we are discussing about the belt drives with the pulleys. We have seen selection of the belts, type of the belts, material is used, what should be the different working stresses, density and material speed should be applicable for selecting the appropriate drive. Now we will discuss the effect of coefficient, what should be the optimum coefficient of friction between the belt and pulley. Now we can calculate, we can identify, we have a standard time table also. So we will discuss it on that. So the coefficient of friction, which is actually depend upon the few parameters. First one is a material of the belt, which kind of material we are using. It is rubber, fabric, cotton. Okay. Then material of the pulley. A pulley material may be steel, then cast. So what kind of material it is? Because it also gives the surface friction, or you can say smoothness of the surface. Then the sleep of the belt depend upon the tension. Then the speed of the belt. Okay. So according to the CG Berth, the coefficient of friction of the oak-tanned leather belt on cast and pulley at the point of slipping is given with the following relation, that mu is equal to, that is mu nothing but is a coefficient of friction, is equal to 0.54 minus 42.6 divided by 152.6 plus v, where v is nothing but the speed of the belt in meter per minute. It is in meter per minute. Okay. So based on the experiment with the different materials and the conditions, we have identified the few values of coefficient of friction for various material of the belt and pulleys. Now look at the belt material is a leather oak tanned, leather chrome tanned, canvas stitched, canvas oven, rubber and ballet. So based on the cast iron or steel material, pulley material is a cast iron or steel. Again, there are three conditions: dry condition, wet condition, and greasy condition. So let's see with the first condition, leather oak tan. In a dry condition, the coefficient of friction is 0.23, but it is increased with the chrome condition, chrome tanned belt. Leather chrome tanned belt having highest coefficient of friction with the cast or steel pulley in a dry section, that is 0.35. Then in wet condition also it have a more coefficient of friction, that is 0.32, and in greasy condition also it is having more coefficient of friction rather than the other type of materials, that is 0.22. So as the condition get changed, the coefficient of friction get reduced. Okay. If the pulley is made by wood, what could be the uh, coefficient of friction? If you go with the cotton one, it is 0.25, but in a chrome tanned leather belt, it is 0.4. So if you observe in the table, the leather chrome tanned belt material is having highest friction among all the materials. So it could be useful for you while selecting the appropriate type of belt material. Okay. So again, depend upon the environmental condition. Rubber we are not using in greasy, ballet we are not using greasy environment. So again, it could be changes its friction depend upon the material. As the wood is there, the friction is lesser. Then compressed paper is there, then friction get increased. Leather face is there, then again it will increase, and rubber face it could be more highest, or you can say pulley material where the highest power transmission could be done. That is, a coefficient of friction would be done based on the pulley material and belt material. Next one is a standard belt thickness and widths. What could be the standard one? Again, it is very important to know what are the standard values of the belt thicknesses and belt widths. So normally the belt standard or you can say thickness of the belt are used 5 mm, 6.5 mm, 8 mm, 10 mm and 12 mm, which are normally used. But what could be the width range for each thicknesses we have just noted down over here. So 5 mm it is normally used with belt width of 35 to 63 mm. For 6.5 it is 50 to 140 mm. For 8 mm it is 90 to 224 mm. In 10 mm for normal belt width is from ranging between 125 to 400, and for 12 it is in between 250 to 600 mm. So generally standard values are based on the R10 series starting from 25 mm to 63 mm, and R20 series which would be start from 71 mm to 600 mm. Okay, so some standard values of the widths are noted over here. So you can check while calculating the value, you can chosen from these of the standard one. Now we know that the belts ends are not joined appropriately, or it is not an endless belt. We need to convert into the endless belt. Okay, so the ends should be joined in appropriate fasteners, or you can say joint, which is mentioned over here. These are the three joints which is normally used: cemented joint, lace joint, and the hinged joint. Okay, so in cemented joint you can look at the figure number 3a, which is given over here. uh, while manufacturing to form the endless belt, it is preferred we are using lesser joints. The laced joint is formed by punching holes in the line across the belt, leaving the margin between the edge and the holes. The rawhide strip is used for lacing the two ends together to form joint. This type of joint is normally known as a stretch stitching rawhide lace joint, which is shown in figure number A. Cemented joint, it is directly, we can say, connected, or you can say using the glue or sticky material, and you can directly paste it on and made a joint. But in case of cement, in case of what we can say stitching joint, in case of stitching joint, we need to punch a hole as shown in figure number B, 3B. The holes are punched from the particular distance of the from the particular distance from the edge of the end, so that the strength could be appropriate. Next one is a metal laced joint. It is as shown in figure in number 3, metal laced joint. So similarly, it is nothing but a staple connection. The points are driven through the flesh side of the belt and clinch on the inside. So sometimes the metal hinge may be fastened to the belt end and connected by the steel or fiber pin, which is shown in figure number 7. Sorry, figure number 3D. Okay, you can look at here and you can understood how it is get last. Okay, It is nothing like it is made like a hook, and in between a pin can be drawn, a pin can be insert, and it is get fastened. Okay, so the efficiencies of these kind of joints has to be understood, because based on again efficiency we can select the belt joining process. So generally with a cemented belt, or you can say cemented endless belt, the efficiency we can achieve up to 90 to 100%. The type of joint is wireless by hand, and the efficiency, sorry, cemented endless belt we can achieve about to 90 to 100% with cemented in a shaft which is lesser strengthened. So the efficiency could be 80 to 90%. Wireless by machine, we can use efficiency is 75 to 85%. Then wireless by hand, it is 70 to 80%. Then rawhide laced, it is 60 to 70%. If we use belt hooks, so it having very less efficiency, is up to 35 to 40%. So we need to use the cemented at factory, the belt ends which is cemented at factory. Now type of the belt drive. There are very different type of belt drive: open belt drive, cross belt drive, quarter turn belt drive, then idler pulleys belt drive, then compound belt drive, staple or cone belt drive, then fast turn and low pulley drives. Okay, so these are the different belt drive system. In open belt drive, the figure shows it's a simplest arrangement of the belt system, which is arranged nothing but the shafts are arranged parallel and rotate in the same direction. In case of driven driver, a pulley A from one side and delivers to the another side to pulley B. This tension in the lower side of the belt will be more and lesser in upper side because it's rotate in a clockwise direction. So the tension as a driver is A and driven is B, so the tension it increase in the lower side rather than the higher side. Okay, so where the tension is more, that called as a tight side, and where tension is very less is called as a slack side. In a cross belt, the belts are get twisted, okay, across, which is shown in figure number 5, which are used shafts arranged parallel and rotate in opposite direction. In these cases, we are using this kind of cross or twisted belt drive. Okay, so if driver is rotating in clockwise, the driven belt will be rotate in anti-clockwise direction because of that cross. Okay, so here also the tight side and slack side will be changed according to the belt, according to the direction. Okay, now we have to consider that at a point where the belt is going to be crossed, it should be rubbed against each other, and there will be expensive wear and tear. In order to avoid this, the shaft should be placed at the maximum distance of 20B. So it is an empirical relation where B is the width of the belt and the speed of belt should be lesser than the 15 meter per second. Okay, that should be uh, we need to consider, or we need to take care. It should not be exceeded than 15 meter per second, and the relation that is given over here that can be maintained. Then quarter turn belt drive. The quarter turn belt drive, also known as a right angle belt drive, which is shown in figure number A and B also you can see. B is absolutely given the 90-degree angle. The shaft arranges at 90-degree and rotate in a different direction. In order to prevent the belt from leaving the belt pulley, the width of face of the pulley should be greater than or equal to 1.5 times of the B, and B is the width of the belt. So in case of pulley cannot arrange in figure number A, then a reversible motion is desirable and the quarter turn belt drive will be having a guided pulley, which is shown in figure number B. Okay. Now belt drive with the idler pulleys. Idler pulleys and play an important role to maintain the tension between the driver and driven pulley. So here we can use the idler pulley over here. The belt drive with the idler pulley, that is also known as a jockey pulley, is used with the shaft arranged parallel when open belt drive cannot be used due to the small angle of contact. We can increase the angle of contact. Okay, so this type of drive is provided to obtain higher velocity ratio when the required for belt tension that cannot be obtained by the other means. Okay, so various arrangements are shown in over here. When it is desired to transmit motion from one shaft to several shafts, all arrangement in a parallel, the belt drive with many idler pulleys are used and it is shown in figure number 8. Okay, so there are multiple drives and we have to rotate with this particular speed. With the speed, we can use such multiple belt drive system. Now compound belt drive, it is nothing but multiple stages. Okay, which is connected to each other, and its figure is itself explanatory. So two drives are connected with each other so that at the end the transmission would be more. Then stepped or cone pulley. This type of arrangement is generally used in lathe machine to transmit or to variation in the speed. Okay, without changing the machine. Okay, so if we change the steps, the variation in speed can be occur. Then fast and loosen pulley. So there is a fast pulley and loose pulley. So it is nothing but a clutch type. Okay. So in fast and loose pulley drive, which is shown in figure number 11, is used when the driver and machine shaft is to be started and stopped whenever we decide without interfacing the driving shaft. So machine is working, but still we need to connect and disconnect the um, machine shaft based on the will of the operator. So in that condition, this loose pulley and fastener pulley will be useful, helpful. Okay, it's like a clutch. So as we press the clutch, the drive is get disengaged, but engine is still starting. Okay, it rotating, but the wheels are get stuck, or you can say stop. Okay, so in similar condition, we can use over here. Then we need to identify the velocity of the belt drive. So to calculate velocity, we need to use the empirical relation, or you can say velocity relation. So that I'm pi d n. Oh, okay. So d1 is the diameter of driver, d2 is the follower, or you can say driven. Then n1 speed of driver and n2 is the speed of follower. So the length of the belt that passes over the driven pulley in 1 minute is pi dn by pi dn. It is pi d1 n1. And for follower, it is pi d2 into. So when we compare, equalize both, we get a an relation, that is a velocity ratio. N2 by N1 is equal to D1 by D2. This is a velocity ratio. If the thickness to be considered, it is N2 by N1 is equal to D1 plus T, D2 plus T. Okay, so in this manner you can find out the velocity ratio, or you can directly calculate the pi dn by 60, pi dn by 60, and compare and make the ratio which is shown in figure. Or simply you can calculate the speed of the last driven pulley to the first driven pulley is equal to the product of diameters of the driven divided by the product of diameter of the drivers. Then sleep of belt, it is a most important phenomenon because it reduces the efficiency and the life. The motion of the belt and pulley assume is a firm friction grip between the belts and the pulleys, but in some time the friction grips becomes insufficient to transmit the power, and this may cause a forward motion small forward motion of the driven without carrying the belt or its power with it. This is called as a sleep of belt, and it is generally expressed in a percentage. The result of belt sleep is to reduce the velocity of ratio of the system, as the sleep of belt is a common phenomena, and thus this belt should be never to be used whether the definite velocity is and very important. So sleep between the driver and the belt is noted as S1, and sleep between the follower and belt is denoted by S2. Okay, so it is nothing but driven pulley. So you can see how we can use the sleep percentage while calculating the velocity ratio. That equation is nothing but 1 minus S1 divided by 100. So it is in a percentage. So that's why we are using here. So the equation for a driven pulley is V1 is equal to pi D1 and 1 divided by 60 into 1 minus S1 divided by 100. Okay, when with the driver pulley, the equation is given. In a driven pulley, similar equation with the pi d and pi d2 and 2 by 60. So it is nothing but v, again it is nothing but v2 into 1 minus, or you can say similar velocity which is used in v1 v2, or if the diameter of same, then v into s2. Okay, so rather than doing this, you can directly go with the thickness equation. N2 divided by n1 is equal to d1 plus t divided by d2 plus t into bracket 1 minus s by 100. Then creep of belt. What is mean by creep phenomena? When the belt passes from the slack side to the tight side, a certain portion of the bend extended certainly, and it contracts again. So it means nothing but extension and contraction can be occurred when the belt is transferred from slack side to tight side, and it occurs in vice versa. So due to these changes of the length, there is a relative motion between the belt and pulley surface. This relative motion is called as a creep. The total effect of the creep is to reduce slightly the speed of the driven pulley or a driver pulley. Considering the creep into the velocity ratio, that is N2 by N1 is equal to D1 plus D1 divided by D2 into E plus root of psi 1 psi 2 divided by E plus root of psi 1, where rho 1 and rho 2, sorry, psi 1 not, it's rho 1. So rho 1 and rho 2 are nothing but the stresses in the belt on the tight and slack side respectively. Rho 1 is a stress in belt in tight side, rho 2 is the stress in belt in a slack side. Is the Young's modulus of the material of the belt. Then how we can calculate the length of the open belt drive. Okay, so considering the simple construction of the open belt drive, okay, and you can find out the length by using these empirical relations. Okay, you can seen such kind of relation in machines, oh sorry, in kind of type of machinery. So I'm not going to explain the total things. If you have any doubt, you can personally ask me. You can just go through these equations. It will be self-explanatory. So our final aim to calculate the length, which is nothing but pi r1 plus r2 plus x plus r1 minus r2 bracket square divided by x. Okay, so terms which is already explained. Okay, then similarly for length of the cross belt, okay, so these equations are very important while calculating the length of the belts. Then power to be transmitted. So the power to be transported is very important. That is nothing but the power transmitted from driver pulley to driven pulley. So there are two different tensions which is occurred. That is a T1 and T2. The tensions in a tight side and tension it in a slack side. So R1, R2 are the radius of driver and driven pulley. V is the velocity of the belt. Okay, so the work done per second is a T1 minus T2 into V, that is Newton meter per second. And power to be transmitted, that is a similar, that is T1 minus T2 into velocity, which should be in a watt. Okay, so the little consideration will be shown that the torque exerted on the driver shaft is T1 minus T2 into R1, and the torque exerted over the driven pulley is T1 minus T2 into R2. So while designing the pulley, you should be consider this torque or forces which is acting on the pulley, and based on that you can calculate the pulley design. The ratio of driving tension for flat belt drive. Okay, so tension which is shown in figure. So T1 is a tension, as we see in T2, we know that there's a tension in the slack side. Theta is an angle of contact in a radiation, which is shown in figure. It is arc of A to B, which is given below. Okay, so for equilibrium forces, we need to calculate, and there are four forces which is normally used. That is the tension in belt at P. These 4 points are actually located over there. Okay, then tension T plus delta T in at point Q, then normal reaction which is given, which is shown in the direction of the center, then the friction force, that is a mu into Rn, which can be perpendicular to the normal reaction because of the coefficient of friction between the belt and pulley. So go through these equations, and finally we can find out the T1 divided by T2 is the e raised to mu theta, which is with this equation we have already known. Just the briefing how the equation is generated is shown over here. Okay, you can refer it. Now centrifugal tension, how we can calculate the centrifugal tension. What is centrifugal tension? Since the belt continuously runs over the pulley, therefore some centrifugal forces is caused. Those effects is to increase the tension in both tight side as well as the slack side. This causes the centrifugal tension is occur because of the centrifugal force. At the lower belt speed, the centrifugal tension is very small, but in higher tension, that is more than 10 meter per second, the tension is greater and it could be considerable while calculating. Okay, how you can calculate? You can refer the figure number 16. M is the mass of the belt per unit length in kg. V is the linear velocity of the belt in meter per second. R is the radius of pulley over which the belt is going to run. And Tc is the centrifugal tension from point P to Q. Okay, so the equation for that calculating the centrifugal tension Fc is equal to mr theta, mr delta theta into d theta is nothing but a derivative v square divided by r, which is certainly r get cancelled, and what we get, the equation Fc is equal to m d theta into v square, that is a linear velocity square. Now again you can put all the values regarding to the uh, find out the derivatives. Okay, you get the actual equation, that is nothing but the centrifugal tension Tc is equal to mv square. Tc is equal to mv square. So when the centrifugal tension is take into account, how we can consider? So in tight side, Td1 is equal to T1 plus Tc. That is a total tension side, and total in a power from T plus Td2. Okay, so here the equation get changed. Next one is the maximum tension in the belt. So maximum tension in the belt we can calculate based on the consideration of different tensions, that is centrifugal tension, that we have considered that TT1 slide side and tack side, which is shown previously. So the maximum centrifugal tension in tight side is a T1 plus Tc, and slack side it is T2 plus Tc. Okay, so when we consider the power transmission is maximum at the 1/3 of the maximum tension is absorbed by centrifugal tension. Okay, so it is a 1/3 tension which is absorbed by centrifugal tension. Centrifugal tension. So there are two equations which can be used to calculating the velocity and tension. Now initial tension in the belt. So that could be because of the coefficient of friction, that is the angle between T1 and T2. You can refer this equation so you can get the initial tension in the belt. Then here a few facts related to the flat pulley is shown here. The pulleys are used to transmit power from one shaft to another shaft by means of flat belt, V-belt, or rope. That is called as a belt pulleys, belt drives. Since the velocity is inverse ratio of the diameter of the driven pulley and driver and driven pulley, therefore the pulley diameter should be select appropriately, because here we are going for pulley design. Okay, so selecting the pulley uh, is very important aspect to maintain the velocity. The pulley must be perfectly aligned in order to allow the belt to be travel in a normal line on the pulley surface. Then the pulley is made up of cast iron, cast steel, pressed steel, wood, and paper. The cast steel material is used with the having a very good friction wear characteristics. The pulleys are made by pressed steel, are lighter than the cast steel. Okay, and but in many cases, due to the lower friction, maybe produce the excessive wear based on the material. Now the type of pulleys. There are 5 types of pulleys which is normally used for power transmission. So first one is a cast iron pulley, which is shown in figure number 17. It is a solid cast iron pulley which is manufactured by using the casting process. The pulleys are generally made by cast iron because of low cost. The rim is held in a place of placed by wave form. The central boss, which is shown in figure, by arms or spokes. We can say arms or spoke. So middle one is called as a boss, and outer one pulley, outer one is called as a rim, and which is connected by the arms, or you can say spokes, as shown in figure. When the cast pulley contracts in the mold, the arms in a state of stresses and very liable to the break. The curved arms tend to yield rather than to break. The arms are nearby to the hub as shown in figure. Okay, so the cast iron pulleys are generally made with the rounded arms. This slight convex, as shown in figure, is called as a crowning because it's not a perfectly flat, and crowning, which will be reduces the runout phenomena of the belt. The crowning is up to the 9 mm for 300 mm width of the best belt pulley face. This cast iron pulley is made from solid, as shown in previous figure also. And the if you are using split type, you can refer the figure number 18, which is joined by using fastener. Okay, so when it is necessary to mount pulley on a shaft which already carried pulleys, uh, which is nothing but a swinging ends are swelled, so it is easily to use split pulley. There is a clearance between the faces, and the two halves are readily tightened upon the shaft by the bolts, which is shown in figure. And a shank key is used for heavy tray. If it is a lighter one, you no need to use a key, but the keys are very important to transmit the power. So you can refer it. Then steel pulley. The steel pulleys are made by the pressed steel sheets and having great strength and durability. But it is lighter than the cast pulley, near about 40 to 60% weight is lesser with the same capacity. Then the present of coefficient of the friction in a leather belting, which is least equal to obtained by the cast iron pulley. The steel pulleys are generally made in two segments or hulls which are bolted together. The clamping action of the hub hold in pulley to the shaft. So thus no key is required to expect the most several services. The steel pulleys are generally equipped with the interchangeable bushing to permit their use with the shaft and different sizes. Okay, the diameter and spoke values are given as per the Indian standard as shown in table. Number of spokes, then the diameter of spoke, which is given over here. As the diameter increases, we need to increase the number of spokes. How we can calculate the length of hub? That is nothing but face width of the face divided by 2. The length of hub should not be exceed than 100 mm for 90 mm diameter spoke and 130 mm for 22 mm diameter spoke. The thickness of rim is generally 5 mm, and the single row spoke is used for a pulley having width of 300 mm, and double row spokes is generally used the width above the 300 mm. Then wooden pulley. Wooden pulleys are very lighter and possessed higher coefficient of friction than the cast iron steel pulley. This pulley is having two-third weight of the cast iron pulley and to carry the similar size. They are generally made from the selected maple, which is laid on the segment and glued together under the heavy pressure. They're kept from absorbing the moisture by protecting the coating of the shells and vanish so that the wrapping may not be occurred. These pulleys are made both solid or split version. So the cast iron hubs and the keys having adjustable bushing, which is a prevent relation between them and the shaft by a frictional resistance setup. These pulleys are used to motor drives, and there is a contact R contact between the pulley face and belt is quite restricted. Next one is a paper pulleys. The paper pulleys are made from the compressed paper fiber and are formed with the metal in the center. These pulleys are generally used for belt transmission from electrical motor where the center distance is very small. Fast and loose pulleys, these pulleys are used to shaft enable machine to start and stop based on the operator will. This construction is as shown in figure. Okay. So remaining part we will discuss in next lecture. I hope you have understood the basic designs aspects. If you have any doubt, you can please contact and ask your doubts. Thank you.